Properties and attributes of polygons. Today we're going to classify polygons based on their sides and angles, and then we're going to find and use the measures of interior angles and exterior angles of the polygons. So the first thing we're going to talk about is what makes a polygon a polygon. So a polygon is a closed plane figure formed by 3 or more segments. So it has to be at least a triangle, 3 sides. Each segment intersects exactly 2 other segments only at their midpoints. That means it can't intersect like in between, not at their endpoints. A side of a polygon, each segment that forms the polygon. So if you see the picture that is over here, the sides are the one that connects the letters, the endpoints. The vertex or vertices of a polygon are the common endpoints of 2 sides. So anytime 2 sides meet, that point is called a vertex. So this would be a vertex, this would be a vertex, this would be a vertex, this would be a vertex. There's 5 vertices on this figure. The next thing is a diagonal. A diagonal is a segment that connects any 2 non-consecutive vertices. Remember, non-consecutive means like not right in a row. Like consecutive would be A and B because they're right beside each other. But non-consecutive would be B and D, or connecting B and E, or connecting A and D, or connecting E and C, or connecting A and C. Alright, so now we're going to name polygons. You'll need to memorize these names. I feel like most of you probably already know, but a 3-sided figure is a triangle. A 4-sided figure is a quadrilateral. 5 sides is pentagon. 6 sides is hexagon. 7 sides is heptagon. 8 sides is octagon. 9 sides is nonagon. 10 sides is decagon. 11 sides is undecagon. 12 sides is dodecagon. And then if I don't know the number of sides, amount of sides, we call it an n-gon. So if I ended up with a figure with 13 sides, it would be a 13gon. Or 20 sides would be a 20gon. Alright, so let's turn over and look at the back side. On the back side, the first thing we're going to talk about is what makes a concave polygon. So a concave polygon is a polygon with a diagonal outside the figure. It also has 1 or more interior angles greater than 180 degrees. So I drew a picture, 1, 2, 3, 4, 5, a pentagon, 5 sides. But when I drew my pentagon, I noticed that I had a diagonal outside the figure because this and this are non-consecutive sides, or vertices, because this vertex is between them. And when I drew the diagonal, I noticed that it was outside the figure, not inside. And I also noticed this angle right here was going to be more than 180 because it's more than 100, well, it's more than 180 degrees because it's more than a straight line. So then a convex polygon is a polygon with all diagonals inside the figure and all interior angles are less than 180. So if I were going to draw this pentagon convex, I would just need all the diagonals inside. Not all the sides have to be the same, but I need all the diagonals inside. So when we talk about the interior sum, angle sum, we take the number of sides and subtract 2 from that and then multiply by 180. So if I'm talking about the interior angle sum theorem, it's the number of sides minus 2, and then we take that times 180. The exterior angle sum, the exterior angle sum of any type of polygon that I ever have is always going to be 360. If I have a 9-sided figure, if I take the angles on the outside and add them up, I'm going to get 360. So remember, when we talk about exterior angles, we're talking about, let me draw a figure here. We're talking about taking a side, extending it out, this angle right here, plus 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 this angle right here. Those would always add up to be 360. So the next thing, a regular polygon, it's when all sides and all angles are equal. So it's equilateral and equiangular. An irregular polygon means all sides and angles are not equal. Oh, not all, there it goes. Not all sides and angles are equal. My bad. So If I measure just each interior angle of a regular polygon, remember regular means that all sides equal, all angles equal. So if I just want to find one measure of one interior angle of a regular polygon, I still use my same formula, the number of sides minus 2 divided by 1 or times 180, but then I divide that by the total number of sides I have. And then if I'm finding the measure of each exterior angle of a regular polygon, so not just all of them added together, but just one exterior angle, that I would take 360 and divide it by the number of sides I have. So let's look at some examples. Example A says, find the sum of the interior angle measure of a convex octagon. So I'm finding the sum of the interior angles, and it's a convex, which means none of the diagonals are on the outside, octagon. And I know an octagon has 8 sides. So since it says the sum of the interior angles, I know my formula is going to be n minus 2 times 180. So that means 8 minus 2 times 180. And that's going to equal 1,080 degrees. Let's look at the next one. Find the measure of each interior angle of a regular nonagon. Now I can only find each measure if it's a regular figure. So I know a nonagon has 9 sides, and I know if I'm finding each, that means one interior angle, it's n minus 2 times 180 and then divided by n. So that would be 9 minus 2 times 180 divided by 9. And that would equal 140 degrees. The next one says, find the measure of each exterior angle of a regular hexagon. Remember, I can only find each interior or exterior angle if the figure is regular, if all the sides are the same. And I know a hexagon has 6 sides. So my formula would be 360 divided by the number of sides. So that would be 360 divided by 6, which would give you 60 degrees for each exterior angle of a hexagon. All right, and the last one, number 9, says find the value of A in the polygon over here. So I know I'm looking at exterior angles, and I know that the sum of the exterior angles of any figure should add up to be 360. So I should take all these sides and add them up to be 360. So 7A plus 2A plus 3A plus 6A plus 2A should equal 360. Let's see, that's 20 A's equals 360. So I solve for A by dividing by 20 to get A equals 18.